Problem 16. 5 balls are arranged on a circle. Chris chooses 2 adjacent balls at random, interchanges them. Sylvia does the same, but her choice is independent of Chris's. And we're trying to find the expected number of balls that occupy their original positions after the 2 successive transpositions. So expected number of balls is just fancy talk for expected value, which is just the average. So average, which is just the sum of numbers over the number of numbers. So now that we have that, let's get it out the way. So this is the original pile. I'm going to call it the original. Oh, that's a terrible box, but so original. So this is ball 1, ball 2, ball 3, ball 4, and ball 5. You can imagine this is a circle, right? And then after Chris's pick, so Chris's pick of 2 balls, let's say it's 1 and 2, it will become 2, 1, 3, 4, and 5. So this is after Chris's selection. So now that Chris has selected it, we know that there's 3 out of order, but we can't choose it yet because Sylvia has to pick her choice. So what kind of balls can Sylvia choose? That's the hard part of the question, is to determine what kind of balls will affect what kind of arrangement. So obviously we know if Sylvia chose 2 and 1, which is completely possible, she will have restored the original order and gone back to the original. So if Sylvia chose, in this case, Chris chose 1 and 2. If Sylvia chose 2 and 1 and swapped them, or 1 and 2, whatever you want to call it, she would have gone back to the original order. And in this case, we would have 5 total balls that are back in its original position. But what if Sylvia did not choose 2 and 1? What if she chose, 2 and 5? If Sylvia chose, 2 and 5, and this is Sylvia, and I'll put an S here just to represent, that's not a 5, that's an S. If she chose 2 and 5, then the order will look like 5, 1, 3, 4, and 2. So what balls are still in their original, positions? So if we look, well, we see that 4 and 3 are the only 2 balls that are in their original position. So in this case, we would get an outcome of 2. So I'll put it in the center and box it up to show you that that's the total number of outcomes. And that's a 5, not an S again. So now that we have that case, these are the 2 adjacent ones. What about she chose 1 and 3? If she chose 1 and 3, so 1 and 3, and this is Sylvia, this becomes the arrangement of 2, 3, 1, 4, 5, right? And what balls are in the original position? And let's separate that. Well, it's obviously 5 and 4. So 5 and 4 are the only ones that are in the original position, so this gives another 2 possible outcomes. So we add 2 and add 2. And we don't know how many there are yet, so let's continue. This is divided by 5 because you have 5 balls total. So 5 plus 2 plus 2, there's another chance, right? That she does not choose one of Chris's and one of unchosen, but rather she chooses 5 and 4. 5 and 4 are unique because in the previous selections, she always chose a ball that Chris has already touched. So now she's choosing 2 balls that Chris has not touched yet, which are 5 and 4. So I know it's getting a little messy, but just bear with me because we are almost done with the question. So if I scroll down a little bit, we go here, which is that she chooses 5 and 4, and that's Sylvia. And if she chose 5 and 4, that's 2, 1, 3, 5, and 4. So what balls are still in the original position? So from this, we know that 4 and 5, so 4 and 5 are out. What about 2 and 1? Oh, wait, we can see here that 4 and 3. Well, 4 and 3 right here, the arrow pointing, is 3's exact position. So 3 is in its good position, so that's good. 2 is here, so 2's out, so 2's out, and 1's out. So 3 is the only, the only ball that's left, which is in their correct position. So there's one case here. But then again, did she have to choose 5 and 4? No, she could have chose 4 and 3, because 4 and 3 are also another case. And that will result in another scenario where she does not pick a ball that Chris has already moved. So she chooses the last possible combination of 4 and 3. This becomes 2, 1, 4, 3, and 5. So if we scroll to the left, we can see that 5 is the only ball that's in the correct position. So there's only one case here. So you add 1, you add 1. Divide this out and you'll be done. So 5 plus 2 is 7, plus 2 is 9, plus 1 is 10, plus another one is 11. 11 divided by 5 gives 2.2. And if we scroll up, we can see that answer choice D is our final answer.